Hey, sixth grade. Today we are moving on to Chapter 3, Section 2. Staying in Chapter 3, we are talking about algebraic expressions and properties. And section number 2 is writing expressions. All right, for our learning target, we've got I can use variables to represent numbers in algebraic expressions. Okay, and we're going to start by looking at some keywords and phrases that are often used in different word problems that give us hints as to which operation we should be doing. Okay, so let's just fill out this graphic organizer here. It's going to be helpful for you to look back at when you're going through some of these word problems. So some keywords and phrases that we use when we're talking about addition are added to, plus is a P-L-U-S is a very common one. Sorry, that looks a little bit sloppy. Sum of, more than, increased by, total of, and lastly, and. All of these different keywords can mean to add. So we've got quite a few different keywords for addition. There's also quite a few for subtracting. We could use subtracted from, minus is a very common one, difference of, less than, decreased by, fewer than, and lastly, take away. Whew, quite a few different keywords for subtraction as well. There's a bit fewer for multiplication and division, thankfully. So multiplication, we've got multiplied by, kind of seems obvious. We've got times, we say that one a lot. Product of, this is one your math book says a lot, but you might not always remember it means multiplication. Twice means to multiply by 2. And last one, of. This is also a big one that you really wouldn't think of, but it's very commonly used. Of in math usually means to multiply. And lastly, for division, we've got divided by and quotient of. So not quite as many, but there are some other ones that aren't listed here. But we're going to use these key phrases to determine which operation we need to use when we have to take these algebraic expressions and turn them into more of a mathematical expression or simplify it. I like to say going from an English sentence to a math sentence, and it's nice because it's almost like abbreviating if you can use your keywords. Right? So for example, one, it says writing numerical expressions. Write the phrase as an expression. In other words, go from this English sentence to a math sentence. All right, 8 fewer than 21. Okay, this is fewer than, if I take a look, is one of my subtraction problems. So fewer than I'm going to replace with a minus sign or subtraction sign. And a lot of students get get this one messed up because they'll say 8 minus 21. Well, if it's 8 fewer than 21, you actually have to start with 21 and subtract 8. So be careful. Remember, subtraction, the order matters. If it says fewer than, actually switch the order of these two from the original problem. And this is all you have to do. You don't even have to find the answer. This is your expression that you need to write, 21 minus 8. Letter B, it says the product of 30 and 9. So if you remember, product of means to multiply. So we would say 30 times 9. Or you could do 30 times 9 like this. You could also use parentheses. There's quite a few different ways to do that. All right, let's move on to example 2, where we write the phrase as an expression. Again, kind of similar, except now we have algebraic expressions. So now we don't just have numbers, but we also have letters, a little bit of algebra. It says 14 more than a number x. More than means to add, so I'll have 14 plus x. You could also have x plus 14. When you use addition, order doesn't matter. You'll still get the same answer. All right, for letter B, a number y minus 75. Again, minus means subtract. So y minus 75. Here, when it says minus, we do keep that same order. And lastly, the quotient of 3 and a number z. Okay, quotient means divide. So we would have 3 divided by z. Or remember, you could also write it as this. That means the same thing, 3 divided by z. All right, why don't you pause the video and try these 6 on your own then. All right, number 1, you should get 18 plus 35. Or again, this could be switched around. It could be 35 plus 18. Number 2, 6 times 50. Or remember, it could be 50 times 6. Order doesn't matter there. Here we have 25 less than a number b. Okay, here we see less than. That means subtract. But if you want to find that answer, you'd have to take b and subtract 25. So be careful with order on subtraction. Whenever you see less than, again, switch the order of those. Number x divided by 4. The total of a number t, so that means add, so we'd have t plus 11, or again, 11 plus t would be the same. And 100 decreased by a number k. So here, when it says decreased by, we're going to keep that same order, 100 minus k. Okay, so order does matter there. It needs to be 100 minus k. Hopefully you did all right. If you have questions, come see me. Example 3 says the length of Interstate 90 from the west coast to the east coast is 153 miles more than 2 times the length of Interstate 15 from southern Cal to northern Montana. Let M be the length of Interstate 15. Which expression can you use to represent the length of Interstate 90? Whew, quite a few key words in here that we need to identify. Okay, so more than is going to tell us that we need to add. So it is the length of I-90 from the west coast to the east coast is 153 more than. So we should be looking for 153.5 added to something. And also it says, okay, I'm going to kind of break up my problem here. 2 times the length of Interstate 15, and I'm calling Interstate 15 M. So 2 times M. All right, where do I see that, and where do I see adding? Well, first off, I can get rid of my 2 subtraction problems because more than means to add. So after I've gotten rid of my subtraction problems there, kind of process of elimination, I'm looking at really next is where my keywords match up with my algebra. So for letter D, it says 153.5 times m plus 2. And for letter A, it says 2 times m plus 153. Well, I know we had talked about adding 153.5 and also 2 times the length of interstate 15. Well, if m is interstate 15, we'd have to take 2 times m. And that's represented here with letter A. So the biggest thing that I think in this problem is just it really takes reading it a couple times to me. If you can do it on the first read, you're probably better at it than I am. But I need to try to match up my numbers with their keywords and reread it, I think are huge helpful things to do. All right, last problem here, example 4 with the real life application. It says you plant a cypress tree that is 10 inches tall. Each year its height increases by 15 inches. Okay, so it's 10 inches to start, and then each year it increases by 15 inches. Make a table that shows the height of the tree for 4 years. Then write an expression for the height after t years. Okay, so that we can stick in any year to find the height. All right, making myself a table here. Might be tricky to make all the lines straight, so sorry about that. But what are the different things I'm talking about? I'm talking about years, and I'm talking about height. Okay, so years, which is represented by the variable t years. So I'll stick that in here. And I'm also talking about the height. And my height is in inches, so I'll include that as well. Okay, well, it needs it for height of the tree for 4 years. Okay, so 0, 1, 2, 3, 4, and then it says, and then I gotta match my height. Okay, at 0 years, so in other words, when you buy it, it is 10 inches tall. So at 0 years, its height is 10 inches. Okay. Now, year 1, it grew. So each year, its height increases by 15 inches. So it's going to be that original 10 inches plus, I'm going to add to that 15 inches per year. And this was only 1 year. So I'm going to put that in there. So we'd come up with a total of, let's see, 10 plus 15 would give me 25 in the first year. Okay. Second year, well, it was still that original 10 when we bought it, plus 15 inches per year. Well, now we've had it for 2 years, so I need to multiply 15 by 2, which would give me 30, plus the original 10 that I bought it at, that would give me 40. And it would be similar for 3 and 4. So the original 10 plus 15 per year, well, it's 3 years now, and the same for the last one, plus 15 times 15 times the 4th year. So 15 times 3, 45, plus 10 will be 55. And if you see the pattern here, it's increasing by 15 inches every year. And that makes sense because it tells us that right here, it increases by 15 inches every year. All right. So lastly, it says, then write an expression for the height after t years. Well, that expression we've just written in here. It is 10, that's the original, plus it grows 15 inches per year. And remember, years we called T. I'm guessing that stands for time. So 15 inches times your years plus the original 10 inches it was would be the expression that I would use to basically classify the height of this tree that it grows each year. All right. Now for letter B, what's really nice is it says, what's the height after 9 years? Well, you could go on and go 5, 6, 7, 8, and get all the way up to 9. That's the slow way. What's nice is now that we have this expression, we can substitute in 9 for our years. So we can take the original 10 inches plus 15 times 9 years that it's grown. Okay. If you were to do the math there, 15 times 9, well, if you just round it to 10, it'd be 150, so just under that. Plus the 10 would give us, so let's see, 145 inches. 145 inches after 9 years. Okay? So hopefully you can see why it's helpful to write an expression rather than having to go through and keep going with this. What if they want to know after 20 years? Well, if you had to go through and do every one of those single calculations, that would get kind of old. Or if you had to add 15 every single time, that would take more time than just using this expression and substituting in your number of years for t. All right, that's all I have for section 2 and writing expressions. If you have any questions, let me know. We'll see you next time.